Hi, 8th grade. Today's lesson is 7-3, adding linear expressions. This is something we did last year, so it shouldn't be too much of a deer in the headlight look for you. Something that you've had experience with, so it should be a short and sweet lesson. So this is 7-3, adding linear expressions. So the first thing we have to talk about is what a linear expression is. It's in the title of the lesson, so let's make sure we know what a linear expression is. It's an algebraic expression in which the variable is raised to the first power. Okay, so that probably doesn't mean a whole lot to you. A linear expression includes numbers, variables, and some form of operation. Okay, usually there are no exponents. That would make it not a linear expression. And nothing too complex. So this would probably make a little more sense to you. Now below I have a few examples of linear expressions. Now let's talk about the word linear. The word linear, the base word is line. So the reason why these below are linear expressions is because if I would graph them on a graph, it would be a straight line. And this is something that we're going to talk about later on in the next few chapters. We're going to be actually graphing equations, plotting points on graphs, and this is just the basics of it. So a linear expression is any time that if you would graph it on a graph, it makes a straight line. These over here are not linear. The reason why these are not linear, if you look over here, this has obviously an exponent that's bigger than 1. The one above it, the 5 times m, there's too much multiplication going on in here. For the most part, if it's a linear expression, there might be multiplication and then some kind of adding something at the end or subtracting something at the end. That one there has a little too much multiplication going on to make it linear if we were to graph it on a graph. So make sure you know the difference. So today we're going to be using these types of expressions. All right, so the only thing I can really do is start by just showing examples. This up here says 3x plus 4 plus 2x plus 1. Now last year I showed you two different ways that you could solve this. Now let me refresh your memory. One way was that we actually put them on top of each other, just like this. And then we separated parts of the problem because this is just like adding the constants. This is adding what's in the x column. The columns are separate, so there's no like regrouping or putting one up top. If you get one bigger than 10, they're completely separate. So it's basically doing two problems in one. So for example, we're going to do 4 plus 1. 4 plus 1 is a positive 5. And then I have 3x plus 2x, I have 5x's. And this would be your answer. Today you can't go any farther because, like, again, we don't know what x is. The other way that we talked about it last year, let me just rewrite this quick. Okay, is we just did something like this. 3x plus 2x, well, I know that's 5x. And then you did the constants 4 plus 1 is a positive 5. And again, we have to make sure we're including the sign in front to help tell us what we're going to do with these numbers. Are we going to add them, subtract them? What's the deal? What are we going to do? So here's my next one. I have negative 4x plus 2 plus negative 2x plus 2. I'm just going to do the first way. I'll do the first way for this one, and then the next way I'll do the second way that I did. Okay, plus negative 2x plus 2. Okay, I'm going to put a line down the middle here. And then I have 2, positive 2 plus positive 2, and I know that's a positive 4. And then I have negative 4 plus negative 2, and that would be a negative 6x. There's my answer. Can't go any farther. Okay, this one, it says 7x plus 2 plus negative x plus 4, and I'm going to follow my rule. If I have a lonely variable, I'm going to put a 1 with it, so that's going to say negative 1x plus 4. So the second way I did like this, 7x plus negative 1. 7x plus negative 1 is 6x. And then I'm going to work with my constants. Positive 2 plus positive 4 is a positive 6. Okay, this is the next one. I wanted to make sure that we include some negatives in here, so make sure you look at this one kind of close. So 4x, and I'm make this a 1x again. So this is 4x plus -1. That would be a 3x. Now I want you to look at the constants. We have to use what we have left over in the sign in front, so don't forget that. It says -3 plus 5. -3 plus 5 is a +2, so I know I'm going to put a plus in here because it's a +2. This sign right here is determined whether or not what sign that this answer is with your constants. The last thing I want to talk about today, I told you, short and sweet video, is a story problem. So the story problem is going to have two things most likely. It's going to say write an expression. Okay. And the second thing, it'll probably say, and I'm going to add this to this one, it's going to say if x equals blank, solve. All right, so this problem says a rectangle has a length of 4x inches and a width of x inches. Find the perimeter of the rectangle. Let's talk about the word perimeter. What's the word perimeter mean? Perimeter is the length around a figure. So if I draw a rectangle, here's my rectangle, okay? Perimeter is going to be all the way around. So if a rectangle has a length of 4x, that means this is 4x. That's not very good. Let's try again. 4x. This is also 4x. If it has a width of x, this would be x. Other width would be x like this. And then, first of all, let's write the expression, meaning what's the perimeter of this thing if I had to figure it out. So that means I'm going to add all my side lengths together. So x plus 4x plus x plus 4x. Well, how many x's do I have? I have 10x. Okay, so my simplified expression is 10x. Now if it said if x is 8 inches, solve. So then you say, okay, if this is 10x, so 10 times x, and if this is what x is, I'm going to substitute this in, and this is what it looks like then. So if x is 8 inches, I know the perimeter of my figure is 80 inches. Okay, I'm going to do another one of those. Let's have a triangle this time. This is my triangle. And let's say that the hypotenuse is 2x plus 1. Let's say the width over here is 3x. And let's say the bottom here is x minus 3. Okay, so the first thing I'm going to do is I'm going to write my expression to find the perimeter. So it would be 2x plus 1 plus 3x plus 1x minus 3. So what I did is I just added all the sides together. I took all these things and I added them together. So now let's put them together. So I have 2x plus 3x plus 1. So let's see, that'd be 6x. And then notice I only have a few constants. I have this and I have this. So it'd be 1 plus -3, which would be a -2. So this is my expression for the perimeter. Now if I said if x is 5, I would take my expression and I'd substitute this in for 5. So it'd be 6 times 5 minus 2. Let's just say it's inches. So it'd be 30 minus 2 would be 28 inches. So read your directions carefully tomorrow or whenever we have class next, because most likely it's going to be asking for 2 things in the directions when it gives you some kind of story problem. The last thing I just need to remind you of is watch your signs and be careful and don't get going too fast, because that's what will get you in trouble also. So thanks for watching, and I hope you took good notes. I will see you next class period.